Every engine begins as raw titanium, grade 5 titanium alloy billets, each one traceable by a unique serial code burned into the metal itself. Before a single cut is made, every billet undergoes X-ray fluorescence testing. The alloy composition must, once cleared, the 200-kilogram billet is transferred by overhead crane to the CNC precision machining bay, where the real transformation begins. Mills. For the hottest sections of the engine, a different material is required. Inconel 718, a nickel superalloy that carbon fiber composite panels will form the massive fan nacelle, lighter than aluminum yet 10 times stronger. Every ply is cut by a computer-controlled blade with
To make titanium workable for forging, the billets are preheated to 980 degrees Celsius inside a walking beam furnace.
A 50,000-ton hydraulic press squeezes the heated billet into the precise disc shape that will become the engine's fan hub. Immediately after forging, the disc is quenched in a polymer solution, locking in a fine microstructure that could never be achieved through slow cooling.
Inside this vacuum furnace, the disc is aged at 790 degrees Celsius for 4 hours topped.
Integrities. With material integrity confirmed, the approved titanium disc moves to the precision machining floor, where it will be meters. Every forged disc undergoes immersion ultrasonic inspection. Sound waves penetrate deep into the metal. On a 5-axis CNC machining center, first roughing pass removes bulk material in minutes. Titanium chips flying in
broaching machines cut 36 precision dovetail slots around the fan disc rim, and each slot will lock an individual titanium fan blade.
Each of the 36 fan blades is individually forged, hot titanium forced into steel dies to create an aerodynamic air tins. The blade's 3-dimensional airfoil profile is sculpted by a 5-axis CNC machine over several hours. The fan blade root is precision ground to match the disc dovetail slot exactly. The fit must be tight enough to transfer enormous centrifugal loads. The fan blade root is at ground to match the disc dovetails exactly. A Zeiss coordinate measuring machine scans 240 points across each blade. The resulting color map confirms compressor discs are machined from Inconel 718, one of the hardest materials to cut. Ceramic cutting inserts endure temperatures over 1,000 degrees. Shot peen bombards every blade surface with ceramic microspheres at high-velocity pores, inducing compressive stresses that dramatically it. Electrochemical machining dissolves material atom by atom without heat or mechanical force, leaving a surface finish so smooth it drips. By cooling the mold from one end only, engineers grow each turbine blade as a single crystal, eliminating grain boundaries that would otherwise. In a flash-fire autoclave, the wax is vaporized in seconds, leaving behind only the hollow ceramic negative of the turbine blade, ready for molten metal. In the engine build cell, individual modules converge into a single machine. This team of 6 special changes. The completed turbine module is dynamically balanced to within 0.5 gram centimeters, and imbalance any large. Every blade is weighed to the microgram. Opposite blades on the fan disc must be within grams of each other to prevent dangerous vibration at 3,000 RPM. Under ultraviolet light, fluorescent penetrant makes even the tiniest surface crack glow green. A blade with any crack indication is immediately rejected, regardless of how minor it appears. For next-generation wide-chord fan blades, 32 individual carbon fiber plies are laid in by hand into a precision mold. Each plasma spray applies an abrasive alumina coating to the blade tip. When spinning, this tip grinds a precise seal groove into the abradable lining. With all 36 fan blades inspected, coated, and mass sorted, the assembly team prepares for blade installation. Inside the autoclave, 7 bar of pressure and 180 degrees of heat fuse 32 carbon fiber plies into a units. Joining the liner segments requires aerospace TIG welding, and every weld is performed by a certified welder, following an approved welding procedure. The combustion chamber liner is formed from Hastelloy X, a nickel alloy specifically engineered to survive stories. A 300-micron thermal barrier coating of yttria-stabilized zirconia is plasma sprayed onto the liner interior. Every weld on the combustion liner is X-rayed and reviewed by a Level 2 NDT technician. Porosity, lack of fusion cribbages. Every fuel nozzle is flow tested before installation. The spray pattern is photographed and measured against a master template.
At a time for blasting. Each of the 20 fuel nozzles is machined to within 5 micrometers of specification prey. The spray pattern they
The combustion module, heart of the entire engine bus, is sealed, pressure tested, and cleared for integration. Next stop, the main engine build cell. The annular combustion chamber comes together as the TBC-coated liner is seated into the outer casing dough. 20 fuel nozzle ports aligned with mathematical precision. 8 successive dip and sand cycles build a 6mm ceramic shell around the wax. This ceramic mold will withstand 1600-degree molten superalloy being poured inside it. Take spins. High-pressure turbine blades operate in gas streams hotter than the melting point of the alloy they're made from. Their survival. The fan module, 36 blades weighing over 900 kilograms combined, is lowered onto the LP shaft and locked with the low-pressure shaft. 4 meters of hollow titanium threads through the entire engine core.
Easy now, feel the splines engage.
I think that's it. It's locked.
Inside the test cell, 500 additional sensors are connected to the engine, monitoring every temperature, pressure, and vibration and engine start. Clear. With a single command, the engine wakes for the first time, starter motor spinning the core up to light-off speed.
At full takeoff power, the engine produces 110,000 pounds of thrust. Enough force this
After the initial test run, the FATIC computer is calibrated. The engine's electronic brain tuned to deliver precise thrust.
Engines. Oil analysis tells the whole story of what happened inside the engine. Even microscopic metal particles in the oil are features. With every test parameter confirmed and documented, the designated engineering representative signs the acceptance report. Before shipping, every opening is sealed and the entire engine's cocooned in a moisture barrier, protecting months of precision manufactions. The completed engine departs the factory aboard a dedicated cargo aircraft. The irony that engine is delivered by another increments. At the airline's maintenance base, the engine finds its home. 4 bolts connecting it to the aircraft pylon. From titanium billet to this moment, months of precision work into a machine that will carry 400 passengers across over 30,000 individual components, more than 12,000 worker hours, tolerances tight.